Hello. Today we are going to see one of the important modulation technique used in amplitude modulation, that is switching modulator. The switching modulator consists of a non-linear device called a diode and a bandpass filter. The input to the non-linear device is the addition of your message signal and a carrier signal. So you can see message signal is added with the carrier signal and the resultant signal is given to a switching diode. The switching diode performs the switching operation and the resultant output is given to a bandpass filter where the unwanted frequencies are removed and S of t consists of only the amplitude modulated wave with desired frequency. So one important thing to be kept in mind is the amplitude and frequency of the carrier wave should be much more higher than the message signal. And second point is the diode acts as a switch here. We are considering it as an ideal diode and it is acting as a switch. That means the switching action, that is on and off action of the diode, depends upon the carrier signal as the amplitude and frequency of the message is very small. Let us go in detail about the working of this diode. You can see the circuit diagram of the switching modulator. So here the carrier wave and a modulating wave are added and it is given to a non-linear diode. So let me take this as AC cos 2 pi FCT. So I told you before that it is a semiconductor diode which acts as a switch. That means it becomes on whenever depending upon the carrier frequency. Okay, so that means here what is V1 of t? According to the circuit diagram, V1 of t is nothing but M of t. Let me take this as M of t for easy understanding. M of t plus C of t. What is C of t? C of t is nothing but the carrier signal. That is, it becomes M of t plus C of t is nothing but AC cos 2 pi FCT. Okay, then output of this switching diode, that is V2 of t, can be written as V1 of t into G of t. This is important. That is output of the switching modulator is given by V1 of t into G of t. What is this G of t? G of t is a rectangular pulse train with a period of 1 by Fc. Why we call it as rectangular pulse train with a period of C? This diode will be in on condition when the carrier is, see this, if this is the carrier signal and the total time period is t and its frequency is fc is equal to 1 by t. Okay. During positive half cycle, the diode will be forward biased. During negative half cycle, the diode will be reverse biased. That means the diode will be functioning only for half cycle. That means from 0 to t by 2. That means for 1 by 2 Fc. This is the frequency. So 1 by 2 Fc, it will be, diode will be in on condition. That means we will be getting the output for the frequency 1 by 2 Fc. Okay. So how this waveform looks like. So let me take this G of t is periodic. Why? Because carrier is periodic in nature. So this G of t can be written as a rectangular pulse train. A rectangular pulse train. So this is G of t. Let me take the amplitude is 1 volt. So since it is for half cycle to 1 by 2 Fc, let me take it as the 1 by 4 FC. So here it is 1 by 4 FC. So totally it will be 1 by 2 FC. So let me generate the equation for this rectangular pulse train and substitute in this equation. We get the output V2 of t. That is a procedure here. So first write V1 of t, then V2 of t is nothing but V1 of t into G of t. So G of t is nothing but a periodic rectangular pulse train. Get the equation for that rectangular pulse, substitute the value in this equation, multiply with V1 of t. We know the value of V1 of t. If you multiply V1 of t and G of t, we get the output V2 of t. So first criteria is, first we will find out the equation for G of t. So we know that a periodic signal can be represented by Fourier series. So let me write first the definition of Fourier series so that you can understand in detail. The definition of Fourier series is given by f of t is a naught plus summation n is equal to 1 to infinity a n cos n omega naught into t plus Pn sine omega naught into t. What is omega naught? Omega naught is 2 pi fc. This is the general expression for Fourier series. As I told you, how it is, G of t is a rectangular pulse and it is periodic in nature and it is symmetric. So I can tell G of t is a even function. So even function means what? G of minus t is equal to G of t. This you call it as even function. If it is odd function, G of minus t is equal to minus G of t. So if you take G of minus t, you will get the same thing. So I can tell that G of t is a even function. So for even function, a naught will not be equal to 0. An also will not be equal to 0. But Pn is equal to for even function. So let me write the resultant equation for our G of t. G of t is a naught plus summation n is equal to 1 to infinity an cos cos n omega naught into t. This is the general equation for G of t. So now what is our task? Find out the value of a naught, find out the value of a1, substitute in v2 of t equation, then we get the final equation. Okay. So how will you find out a1 of t? Sorry, a naught. A naught is given by 1 by t into, this is a general expression, t naught to t naught plus t into G of t into tt. So what is t? T is nothing but the total time period. So total time period, what is the total time period we have taken for carrier signal? It is total time is equal to 1 by fc. Right? So T naught, what is the value of T naught? So since you just remember how I have written, it is minus 1 by 4 fc2 plus 1 by 4 fc. So for all other values, let me write initially. So it is T naught means initial value, it is 1 by T, it is 1 divided by 1 by Fc into, starting from minus 1 by 4 Fc, it is ending at minus 1 by 4 Fc plus T. T is nothing but 1 by Fc. What is the amplitude of G of T? 1. 1 into dt. So what you get, A naught is equal to Fc. 1 divided by 1 by Fc is nothing but you get Fc. And you can see here the wave is existing from only minus 1 by 4 to plus 1 by 4. For all other values in that time period, since it is a periodic time, in that particular time period, the wave is not there. I mean, the pulse is not there. So I will be taking the 1 by minus 1 by 4 fc to plus 1 by 4 fc. Why? Because for all other values, the pulse will not be visible. So it is 1 into dt. So when you simplify, you get fc. What is the integration of 1 t? Substitute upper limit and lower limit. 1 minus 1 by 4 fc2 plus 1 by 4 fc. You get a naught is equal to 1 by 2. So now you got the a naught value. A naught value is done. Next you have to find out the value of an. So how will you find out the value of an? An is equal to 2 by t integration from t naught to t naught plus t g of t into cos 2 pi fct into dt. This is the equation for finding an. So what you get? You get 2 by t. Once again t naught to t naught plus t will become minus 1 by 4 fc2 plus 1 by 4 fc. G of t is 1 into cos 2 pi fct into dt. So what is the integration of cos 2 pi fct? So this t can be written as 1 by fc. So this will become an is equal to 2 into fc. Integration of cos is sine. It is cos n 2 pi fct. So it is sine 2 pi fct divided by n 2 pi fct. This is the integration for cos. Substitute upper limit 1 by 4 fct minus 1 by 4 fc2 plus 1 by 4 fc. So when you substitute this and simplify, you get an is equal to 2 by n pi into sine n pi by 2. So keep this as equation 3 and this is equation 4. Now substitute the value of a naught and an in the main equation of g of t. So what you get? So my g of t becomes g of t is equal to a naught. A naught value is 1 by 2 plus summation n is equal to 1 to infinity an. An is 2 by n pi sine n pi by 2 into cos n 2 pi fct. Okay. Now what to do? 1 by 2 will remain as it is. Substitute the value of n is equal to 1, 2, 3, 4. So let me substitute for only 3 values. So n is equal to 1. When you substitute n is equal to 1, you will get 2 by pi sine pi by 2 into cos n is equal to 1 means you get 2 pi fct plus n is 1 is over. Next substitute n is equal to 2. When I substitute n is equal to 2, here you get 2 pi. So sine 2 pi by 2 is nothing but sine pi. So sine pi you get 0. So you will not have any value here. Now I will substitute n is equal to 3. When I substitute n is equal to 3, you will get 2 by 3 pi sine 3 pi by 2 into cos 3 2s are 6 pi fct plus keep on you will be substituting the values. For time being, I'll end here. Okay. So now what is the value of g of t? G of t is 1 by 2 plus 2 by pi. What is sine 90? Is 1. So it is cos 2 pi fct plus 0. So here you get sine 180 into 3 by 2. So you will get the negative value here. So it becomes minus 2 by 3 pi cos 6 pi fct plus so on values. So now this is the equation for g of t, right? So this g of t should be substituted in our original equation, that is final equation v2 of t is nothing but v1 of t into g of t. So v1 of t, I will write m of t plus cos 2 pi fct into g of t is 1 by 2 plus 2 by pi cos 2 pi fct, sorry, fct minus 2 by 3 pi cos 6 pi fct and so on. You will have some values there. Okay. So now when I multiply inside, what will happen? You will get v2 of t is equal to, I'll multiply this m of t inside this, multiply m of t inside this, then I'll multiply m of t. So no need to multiply with higher frequency values, because even though you multiply now and get the values, when this v2 of t is given to a band pass filter which is designed for cutoff frequency, so higher frequencies getting eliminated, so no need to multiply here. So what you get, v2 of t, v2 of t, you get it as m of t plus 2 by pi into m of t cos 2 pi fct plus plus 2 by pi m of t cos 2 pi fct plus 1 by 2 cos 2 pi fct plus 2 by pi cos square 2 pi fct. So this is the value you get, and you will have some other values here. So what is the value of V2 of t? V2 of t is nothing but, so when V2 of t is given to a band pass filter, you will get the final value of S of t. So that is amplitude modulated signal S of t, you get it as M of t plus 2 by pi into M of t cos 2 pi fct. Because since it is cos square, higher order frequencies are eliminated. So this is M of t. So S of t is equal to, when you take M of t common, you will get 1 plus 2 by pi cos 2 pi fct. So you're including the amplitude of carrier as AC cos 2 pi fct, you will get AC here, get AC here. Yes, now observe the equation of S of t. So now what is your S of t equation? S of t is equal to M of t into 1 plus 2 into AC by pi cos 2 pi FCT. So you know the standard equation of S of t is equal to m of t, sorry, m of standard equation as AC into 1 plus Ka m of t into cos 2 pi FCT. We know that this is the standard equation. Now we are bringing that equation, our S of t is equal to, if you take AC by 2 common in this equation, you get 1 plus 4 by pi into AC m of t into cos 2 pi FCT. This is the output equation from switching modulator, which is proportional to your amplitude modulated wave, whereas Ka can be amplitude sensitivity of this modulator is given by 4 by pi AC. Thank you.